When this tower crane has finally been assembled and the driver's in his cab, he probably won't give a thought to the way it was put together. But joining things is probably one of the most fundamental processes in engineering. Traditional fastenings, like nuts and bolts, are still one of the most useful methods, particularly when the joint is only a temporary one. A plain, flat washer under the nut serves a number of purposes. Can you think what they are? A tower crane can have as many as 14 sections, like the two they're joining here. And each joint must be bolted tightly enough to withstand the forces involved when the crane is in action. Engineers have worked out in advance exactly how much torque they need to apply to the nut for the maximum force the joint will have to take. Friction between the mating threads on the nut and bolt and between the nut and the clamped assembly will help to keep the joint tight. It'll also help to stop the nut coming loose, but just to make sure, they finish off the job with a spring steel nut to lock the fastening securely. If the bolts are fitted horizontally, the load on them is different and a simpler technique is used. Notice that the washer is split. Can you think how it'll help to stop the nut vibrating loose? Every bolt is designed to take just so much torque. You may be tempted to give a nut a few extra turns for a really tight joint. But this is what can happen. The bolt shears just below the nut. And can you see what's wrong here? The lower edge of this nut bears down extra heavily on the surface of the component. By using a taper washer, you distribute the load evenly over the surface of the assembly. When an assembly job has to be carried out on site, on a crane for example, or this pylon, the traditional nut and bolt is a very convenient and cheap method of fastening. So far, we've only looked at structural steel assemblies, but civil engineering techniques have created many new needs. In a building like this one, literally thousands of fastenings will have to be used. One problem is how you fasten into concrete masonry, and here's one method. This is how it works. As you tighten the bolt, a metal wedge is drawn up inside a loose metal shield. The sides of the shield expand and are forced against the surrounding concrete, biting into the masonry to provide a really firm grip. The self-drilling anchor is another very common fastening. It has a cutting edge of its own, and you use the anchor itself as a drill bit. This way, you can be certain you're drilling a hole of exactly the right diameter. After drilling the hole, a small wedge is inserted into the end of the anchor. When it's driven back into the hole, this wedge forces the ends of the anchor outwards to grip the surrounding masonry. It's then broken off from the end of the drill and left behind in the concrete to provide an anchor, for a bracket perhaps. Literally thousands of these anchors will be used in this particular building to carry brackets for hot water pipes, electrical conduits and many other fittings. The type you use depends on the material you're fastening into. This one has to be fired in because the masonry is too hard to be drilled. On a building site, most assemblies are static. The load on the joint hardly varies. But wherever you have movement, this load will change. A joint may be subjected to vibrations or sudden sharp impacts. This experiment shows what can happen to an ordinary nut and bolt if the joint is vibrated. The nut is first tightened. These markers will show you precisely what happens to the nut when the joint is vibrated at about 800 revs per minute. The nut comes undone in seconds. It could have been worse. This nut is out of round. As you tighten it onto the bolt, the two threads jam together. Compare it with an ordinary nut. The out of round one stays locked onto the bolt. It's one of a whole class of fastenings called stiff nuts. This one locks onto the bolt because of a nylon insert. It stays on even if there's no tension in the bolt. The manufacturers don't really expect you to treat your washing machine quite like this. We've deliberately put an unbalanced load in to exaggerate the effect of the spin drying cycle. But you can't see any nuts flying off here. In this kind of light assembly work, you can use a lock washer to keep the nut in place. This one increases friction between the assembly and the nut by means of teeth which bite into the two surfaces. If the joint has to take a heavier load, a spring washer is more effective. Can you see how this one works? Here's another useful fastening, the circlip. It's lightweight and easy to fit. It's particularly suitable for a component which has to be rotated on a vibrating assembly. In the aircraft industry, much stronger types of fastening are needed. The fuselage is mainly riveted. But where panels have to be removable, you need a strong fastening which will not only withstand shocks and vibrations, but also be easy to undo. Since the joint is only accessible from one side, this fastening is made in two parts. One half is actually built into the fuselage. And here's the other half. It can be removed as quickly as it's fitted. Sometimes nuts are secured by wiring them together. The wire may pass through the nuts only, or it can be threaded through the bolt itself. Drilling a hole in a bolt is a very tricky maneuver. But the slotted nut or castle nut provides a very effective fastening. After the nut has been tightened, it's secured by a split pin which passes right through the bolt. The position of the hole has been very carefully determined. All this is time-consuming and therefore costly, but this is one of the strongest methods of locking a nut onto a bolt. It's a mechanical method rather than a friction one, and on an aircraft like this fighter, the fastenings will have to take a lot of punishment. A technical drawing is supposed to tell you everything you need to know to assemble a component. This part specifies the screw you'll need. But can you understand it? What does the M signify? It tells you which thread form is required. There are several in use, but they all have this basic V-shaped profile. What does the 1 refer to? It's the distance between corresponding points on the thread. This is called the pitch, and it tells you how coarse or fine the thread is. And what does the 6 measure? It tells you this diameter. The strength of the screw depends on this, and it's called the major diameter. And this tells you the minimum length of screw thread required for the job. Lastly, full thread. Which one of these three won't do? Well, this bright lad managed to select just the right one for the job. Probably the commonest way we use screw threads is for fastening things together, but there are many other uses. Thread cutting can be done to a very high degree of accuracy, and this is useful in the design of measuring instruments. For example, the micrometer. Its accuracy depends on a precision-made screw thread. The thread has a pitch of 0.5 millimeter. So, for one full turn of the thimble, the gap between these faces changes by precisely that amount. Again, it has a V-form profile, and you could find many more uses of this type of thread. The great advantage is that it can be machined easily and accurately. On a fly press, you see a V-form thread being used for fine adjustment. But here, the V-form is superimposed on a different type of thread. This is an Acme thread form. You usually find it wherever a thread is needed to transmit motion. In a bench vise, you use another kind of thread. It helps with the quick release mechanism, this half nut. It also helps to transmit load. You can see how if we look more closely. It's called a buttress thread. Force is applied through the square faces, but in the forward direction only. A center lathe also has a split nut action. But in this case, you want to transmit both movement and load in 2 directions. So you use an Acme thread. Some fastening methods don't rely on the action of a screw thread. Solid riveting may be one of the oldest joining methods, but it's still an important one. On the aluminium fuselage of this fighter, they need rivets which are light as well as strong. These rivets are made from an aluminium alloy. The choice of rivet head depends on the particular design requirement. These are rounded. They're called snap head rivets. But elsewhere on the fuselage, you'll find other types of head. Where a really flat surface finish is required, the rivets are always countersunk. These rivets are made from an aluminium alloy which hardens with time. If used in this hard state, they'd be liable to fracture. So, before use, they must be softened by heat treatment. First, the rivets are immersed in a salt bath. This keeps them at a uniform temperature of 500 degrees Celsius or centigrade. After half an hour, they're removed from the bath and quenched in cold water. This sequence of heating and rapid cooling softens this particular material. After quenching, they're cleaned by being dipped into methylated spirits. Then they're stored in a fridge until they're needed. This slows down the age hardening process. But you can't stop age hardening altogether. On the shop floor, they use colour-coded containers so that men working on each shift can be certain of using rivets which are strong but not hard. Solid riveting requires two people with access to the joint from both sides, but this is a different riveting technique. The aircraft industry created a more special need, a process for riveting a joint when access is only possible from one side. Blind rivets provided the answer, and now they're used throughout engineering as a standard sheet metal fastening. A blind rivet is hollow, but this type is pre-assembled on a pin which fits into a special gun. As the gun fires, the tail breaks off and a head is formed on the blind side of the joint. This animation shows the basic principle. First, the tail of the rivet is expanded, and then the shank to fill the hole and clench the joint. But this is only one of a wide range of automatic riveting techniques. Joining things together is a basic industrial operation. Though blind rivets are more costly to produce than solid ones, they're quick and easy to apply. Cost is one important factor in deciding how to join things. The type